Now everyone, let us talk about the next topic, half-life. Yes, as the name suggests, what will be the meaning of half-life? Half-life of the reactant. Half-life. Yeah. What will be the meaning of half-life? One side of the reaction, is it? No. Half-life. It's in the name only. Or half-life time, you can say. Half-life time. Half-life time. It is denoted by T half. Denoted by T half. 50%. See, suppose I am having a reaction A giving B. Okay, A giving B. Now I have started, let us say from any random number, I have started from 80. Okay, my concentration of A is 80. Now, what is T half? That is time taken by a reactant. Okay, time taken for an 80 to reach 40. Okay, time taken for your yes, time taken for your final concentration to become half of the initial concentration. Time taken by a reactant to become, yes, time taken by your final product to reach 50% of half of initial value. Are you getting it, everyone? That is nothing but T half. That is nothing but T half. That is time taken by your reactant to become 50% of the initial concentration. 50% of your initial concentration. Okay. So what do I mean by this? Look over here. Look over here, everyone. So what happens? Initial concentration, we take it as R naught. Yes, initial concentration, we take it as R naught. Yeah. Final concentration, we write it as R. So what is T half? What is T half? That is time taken by your final concentration to become half of the initial. Half of the initial. Okay, so let us say initial is, let us say any word, 120, any number, 120. So time taken by it to become 1 by 2 into 120, that is 60. Okay, so time taken for your final reactant, time taken by a reactant to become half of the initial concentration. Is it clear, everyone? Is it clear? Yes or no? No. Hari bhai, that is what I am telling you. Let us say we are going opposite. No, over here we are going opposite. Look over here. Let us say initial concentration you have R naught. Okay, initial concentration is R naught. Okay, so whenever your reactant goes to product, what happens? Concentration decreases. Whenever the reactant goes to product, Hari Mahesh, the concentration decreases. Okay, so let us say over here, give me any number. Let us say the concentration is 200. Okay, I am taking any random number. Concentration is 200. Okay, so after certain time t, your initial concentration goes on decreasing of the reactant. I am saying of the reactant, it goes on decreasing. Yes or no, everyone? After certain time t, initial concentration of reactant goes on decreasing because reactant is going into product. So initial concentration goes on decreasing. So this decrease, okay, it will reach till 100. That means 50% of concentration. 50% of concentration. So this time taken for your final reactant or your final product, okay, time taken for your reactant, okay, to become half of the initial value. So this has become half of the initial value. Are you getting it, Hari Mahesh? This has become half of the initial value. Everyone, is it clear now? Is it clear? Is it clear, Shrutika, Shrusti, is it clear? Okay. Now look over here. Let us do this. Let us do this. Now let us find out first for the zero order. Okay. For the zero order, what was the rate constant? We started with it. For the zero order, the rate constant was K is equal to R naught minus R over T. Yes, this was my rate constant for your zero order reaction. Now at T half, yes, what will happen at T half? My T will become T half. My initial concentration, yes, what will change? What will change? My final concentration will become half of the initial concentration. My final concentration will become half of the initial concentration. So I can write over here at T half, K is equal to, now R naught as it is, minus my R has become half R naught over T. Is it clear, everyone? Is this step clear? Please look at it and tell me, is this step clear? Yes or no in the chat box. Is this step clear? Yeah, tell me, is this step clear, everyone? Okay. Now, again, what I'll write, half R naught T. Yes, so basically it is R naught by 2T. R naught by 2T. That is nothing but, oh, that will not be T. T will go to that side, no? This is a T half. T half will go to that side. This will become K. This will become K. So this will be. Is it clear, everyone? This is T half. Is it clear, or do you want me to explain again? Come on, tell me, is it clear? Clear or no? If it is not, please tell me. I'll explain you once again. Is it clear? Come on, go ahead, write it down and done in the chat box. Okay. Can I explain the last step again? Okay, look over here, Jyotsna. Look over here. Let me erase this. Look over here. I'll explain this once again, the last step. Okay. So over here, Jyotsna, what I have done, I have written T half to that side, to the numerator, K to the denominator. So T half is equal to R naught minus half R naught, R naught minus half R naught over K. Now 1 minus half, we know it is equal to, we know, half R naught over T. So Jyotsna, I can write it as simply R naught over 2T. R naught over 2T. Yeah. Sorry. Again, I have written T. It should not be T. It should be K. Correct. This is K. This is K. This is T half. So again, T will become K. So this R naught over 2. That is a T half. Is it clear now? Is it done, everyone? Come on, write it down and done in the chat box. Now this was your done. Okay. This was your T half for exclusively right on the top. It is zero order. Do not use this for the first order. This is for your zero order. Okay. Now everyone, let us go to the first order. Let us go to the first order. Okay. Now let us go to the first order. Now for the first order, we have seen, for the first order, yes, for the first order, we have already seen the rate constant. Yes, K is equal to 2.303. Yes, K is equal to 2.303 T log of, yes, R naught by R, log of initial over final. Yes or no? Initial over final. correct? Again, at T half, what will happen? At half life, what will happen? My T will become T half. Yes, my T will become T half, everyone. Then my R, yes, my final concentration will become half of the initial concentration. My final concentration will become half of the initial concentration. Correct? So if I substitute that, so K is equal to 2.303 by T. Yes, T will become T half log R naught remain as it is. Now instead of R, I can write it as R naught by 2. So that I can write it as R naught over here, 2 over here. Yes, R naught by 2, 2 goes in the numerator. 2 goes in the numerator. So R naught cancel. T half goes to that side. So what did I get? T half is equal to 2.303 K log 2. And what is the value of log 2? We all know it is 0.301. So T half is equal to 2.303 K log 2 is 0.301. So if I multiply 0.301 everyone by 2.303, what do I get is 0.693. So finally my T half is what? T half is equal to 0.693 over K. 0.693 over K. 0.693 over K. Point 693 over 0.693 over. This is clear. You know, you should, after every concept, instead of me shouting, is it clear? Is it clear? You can write it from yourself only. No, it is clear. Will save a lot of my energy, isn't it, Hari Mahesh? Isn't it? Will save a lot of my energy. Instead of me shouting, is it clear? Is it done? Yeah. You know, I am going to ask after every step, after every concept is done, I'm always going to ask you, is it clear? In that tone, you know, is it clear? If it is not, please tell me. So better you only, whenever the concept is over, it is better that you only tell me it is clear, sir. No need of wasting energy on us. It is clear. You can stop. Come on, write it down and tell me done. You can type. Uh, yeah, I can type obviously. Done. Come on, give me a longer done. And turn on your cameras, please. Okay. So this was your half-life. Now, if you notice something, over here, in this first order, we do not have, any type of concentration. Yes. So write it down, everyone. Your first order T half, the half-life of first order, yes, T half is independent of concentration of reactant. T half is independent of, write it down, T half is, this can come into statement type of question. T half is independent of concentration of reactant. T half is independent of concentration of reactant. T half is independent of concentration of reactant. Chalo. Let us go ahead. Now after this, Just a small part you have, just for your knowledge, that is, how do we pronounce this? Yeah, how do we pronounce this? Write down your pronunciation. How do we pronounce this? Pseudo. Yeah, how do we pronounce this? Yes, it is pseudo. What is the meaning of pseudo in English? It is the brother of Ludo. Yeah. What is the meaning of pseudo in English? What is the meaning of pseudo? Hari Mahesh, Srishti, Shrutika. What is the meaning of pseudo in English? Yeah. False. Fake. Yes. Correct. Correct. That is pseudo first order reaction. Pseudo means false. Now you only can imagine. Yeah. Pseudo first order reaction. Pseudo first order reaction. That means what? False first order reaction. False first order reaction. Yes. False first order reaction. So over here, now what is this pseudo first order reaction? Okay, what is this pseudo first order reaction? So over here, what happens, that the reaction actually wants to behave like a second order reaction. Okay, the reaction wants to behave like a second order reaction, but but it behaves as a first order reaction, Okay, so such reactions are called as pseudo first order reaction. When the reaction wants to behave as a second order reaction, but it behaves as a first order reaction. Yeah, it is called as pseudo first order reaction. Yeah, so like what is the pseudo first order and why does it behave like a pseudo first order? Look over here. Suppose everyone, I have this CH3 COOC2H5. Which functional group is this? Everyone? Yes. Now organic people, soon we are going to start it. Which functional group is this? Yeah, ether. Wow. Tell me, I'll get to know how much I have to work on your organic. Yeah. Which functional group is this? A lot. Why it is confusing? It is straightforward. Okay, chalo, I'll make it more easy. I'll write it more in a more easy way. CH3. Now tell me. Hmm. Wow. Hari Mahesh. Wow. How it can be acid? Does it has H plus? But which is the functional group? Srushti, I do not want the name. What is the functional group? R C O O R. It is nothing but an ester. Yes, it is an ester. Your carboxylic acid, Harimahesh, it is RCOOH, not OOR. Do not say it is close. It is not. Meaning completely changes. It is an ester. So when you have ester, okay, and if I add alcohol to it, always and always remember, whenever you have ester, and when you do the hydrolysis of ester, okay, when you do the hydrolysis of ester, what do you have? Water means H plus and OH minus, correct? H plus and OH minus. So if I break over here, everyone, this is negative, this is positive. So OH minus will come over here at the positive, yes. So what did you get? CH3, C double bond O, OH plus C2H5O, and this H will come together to give you C2H5OH. Correct? C2H5OH. Okay. C2H5OH. C2H5OH. So when this was studied, no, when this was studied, okay, when this was studied, everyone believed that, okay, everyone believed that the rate is proportional to the both of them. Rate is proportional to the both of them. Rate will be proportional to the ester as well as water. Rate will be proportional to ester as well as water, because when they started the reaction, okay, when they started the reaction, they required lot of water. Okay, 10 mole over here, they required 0.01 mole over here. Okay, so this was the starting. P is equal to 0, this 0, 0, and when after certain time t, what has happened, this 0.01, 0, okay, this has used 0.1, so this was 9.9, okay, and this was 0.01, 0.01. So over here, what they noticed, everyone, that this 10 mole, okay, is becoming 9.9, but the product, if you notice, it is only this, okay. So it was only and only was getting altered by the ester. It was not getting altered by the water. This was supposed to happen. If this would have happened, this is 1, this is 1, so this would have been second order. But it was found out that although it looks like a second order reaction, but it does not behave as a second order. Why? Because when you change the H2O, it is not affecting the product. When you change the H2O, it is not affecting the product. That means it is, yes, that means it is independent of your water. Yes. So over here, H2O is not changing anything. That's why the rate is equal to K and only ester. Hence, this is behaving as a pseudo first order reaction. Pseudo first order reaction. Pseudo first order reaction. Is it clear, everyone? Is it clear, or should I have to shout it more? Is it clear, everyone? This is nothing but pseudo first order. Come on, write it down. Write it down, and done in the chat box. Come on, go ahead. Write it down. Write it down, everyone. In the next lecture, we'll do numericals. Okay. Today, let us complete this part. All the numericals we'll do together. Hello, everyone. Turn on your cameras. Let us go to the next concept. Okay. Write down one more example for this. Write down one more example for this. That is your cane sugar hydrolysis. Your sugar hydrolysis C12H22O11. If I hydrolyze this, what will happen? Yes. If I hydrolyze this, what will happen? Haribahesh, Dharneshwar, Sai, Yasira, Srushti, turn on your cameras. It will dissolve. It will break down into two things, you know. If I cane sugar, that is, if you hydrolyze this, if you do the reaction, yes, if you do the reaction, it will break down in what? It will break down in what? What? Fructose and sucrose. It is not fructose and sucrose. It is glucose and fructose. What? Sucrose. It is glucose and fructose. I have to work a lot on the organic. I could see that. Biomolecules, we have to work a lot on that. And you know, this is the common excuse of all the JEE students. Biomolecules, sir. It is physics. We like physics. We are from JEE. Yeah. Biology we do not study. So how we will know biomolecule? Yeah. Hmm. So over here, glucose C6H12O6, fructose is also C6H12O6. Yeah. Now this is independent of water. Again, over here also this should behave as a second order, but it behaves as a first order, only dependent on the cane sugar. Only dependent on the cane sugar. Only dependent on the cane sugar. Is it clear till over here? Can we go ahead now? And we go ahead. Yeah. In my school, biomolecules is completed. Oh my god. Yes, we will study that, Haribai. I'm not going to answer it now. You stay in suspense. Vishwanath says in his school, biomolecule is completed. What? They have started like from the opposite end or what? Not in the order. Achha. You mean they are on almost last chapter of your CBSE? First easy topics. Oh. Sure, let us go ahead now. Now, from the beginning of the chemical kinetics, we are talking about, reactant. Parikshit says in his school they started first organic chemistry. Come on, everyone, tell me, raise your hand. How many of you have started organic chemistry in the school? Parikshit, Shrutika, Hari Mahesh, Srushti, all of you? One chapter from volume 1, one chapter from volume 2. Only hello alkenes. Then we switch. Yeah, then your sir would have seen your conditions. That's why he switched. But are you finding like organic chemistry, like, are you understanding that? Like, what is your scenario? Where do you stand? Like, do you understand organic chemistry to a good extent? No, I'm not worried. I'm happy that I can then start from very basic. I love to teach organic. Organic is my specialty. Okay, I avoid going to very deep. Okay, I avoid to teach from very basic. But if you do not know, like if you are struggling with organic, then I have to teach you from basic, and I love to do that because organic is my favorite topic. I am the organic specialist. Okay, so I am happy that you do not know. Shalom. Don't worry, organic, I'll tell you, organic is one of the easiest thing over here. Only thing to decode organic chemistry is you have to practice a lot. Okay. Like if I teach you now and if I ask you after half an hour, you would have forgotten everything. Okay. So that's why for organic chemistry, you have to write and practice a lot. That is the only way. That is the only way to learn organic chemistry, that you write it and do it. Okay, when I teach you, you'll understand 100% and you'll say, yes, sir, in a good long this. But if I ask you in the next lecture, you'll be forgetting that. That is 100% sure. And that is the normal organic nature. So we have to practice a lot. That is the only thing for the organic. Chalo everyone, let us now, let us go to the next. Let us go to the next. Your temperature. Now, where was I? Now, from the beginning, everyone, from the beginning, we are talking about everything related to the concentration. Yes, everything related to the concentration. Till now, we have not talked about anything regarding temperature. Yes, anything regarding temperature. So, over here, your Arrhenius. Okay, over here, Arrhenius is come into the picture. Arrhenius has come into the picture, and Arrhenius is like, wait, I'll talk about temperature. You all do not want to increase the syllabus of everyone. I'll increase the syllabus. Okay. So Arrhenius came and he started. Arrhenius came and he started he started with the temperature, he started with the study of the temperature, okay, and he found out that some common sense thing, like if I increase the temperature, suppose you are doing a gaseous reaction, you tell me, will the temperature increase, affect the rate of the reaction? Rate means speed. Will the temperature increase or decrease will affect the speed of the reaction? What do you think? Yes, it will affect. Yes, it will affect. And how it will affect? If you increase the temperature, okay, Dharmeshwar, if you increase the temperature, okay, if you increase the temperature, what will happen to the speed of the reaction? Generally, it will, yes, generally it will increase or decrease. Yes, it will increase. It will increase. It will increase. Isn't that a common sense? Yeah. But that time it was not. That time it was not. Now it is. Okay. Sometimes I wonder, we could have born in that era, no? We could have at least searched. We could have at least done the research of that time. Yes, with a good IQ, isn't it? Okay. So over here in the temperature dependence which I have now, I'm tired of writing. I have that in the PPT. Okay, look over here. I'm tired of writing. Enough. I'll teach you from the PPT. Okay. Look over here, everyone. So Arrhenius came in and he gave us one equation. So he told us that if you rise the temperature only by 10 degree, okay, you increase the temperature just by 10 degree, your rate constant is nearly doubled directly. Okay, that is exponential growth. Yes, isn't it? That is exponential. That is the exponential growth. And that's why he gave us the one equation, that is K is equal to A into exponential minus EA by RT. Minus EA by RT. Yes, minus EA by RT. And over here, everyone, EA is nothing but activation energy. EA is nothing but activation energy. EA is activation energy. EA is nothing but activation energy. What is activation energy, everyone? Come on, tell me. Do not say, please do not give the answer. Energy required to activate the reactant or product. No. I do not want that answer. What? Activation energy. I've already crossed out the answer that you were going to give. Okay. Do not want that answer. Energy required to activate. No. What is activation energy, everyone? Yeah? What is activation energy? Yes, everyone. What is activation energy? Energy produced. Can we produce energy? Parikshit. Very wrong word. So, energy produced. What? Are we God? No, na? Energy get activated. Energy get activated. How energy gets activated? Please tell me. What? Is it your TV remote or what? Energy gets activated. Energy itself gets activated. Now, till now I was saying do not say reactant or product. Maybe increases. No. What are we creating a science fiction movie over here? Activation energy. See, whenever look over here, I'll tell you what is activation energy. Do not give me wild guessing answer. Okay, some wild answers I'm getting. Someone is producing energy, someone is activating energy. Okay, no. Look over here. Whenever we go reactant to product. Okay, whenever we go reactant to product, okay, we require certain amount of energy. Correct? We require certain amount of energy. So let us say, suppose, look over here. Look at this graph. Okay. Now, this is my reactant. This is my product. This is my reactant A. This is my product B. So A is going to give me B. Okay. So what happens to go from A to B, our reactant requires certain type of energy, certain amount of energy, correct? That energy, the minimum amount of energy, yes, what happens? It gains energy, it reaches the peak, starts converting into product. So after this much energy only, it will go into product. If it receives, if it receives energy till over here, it will not go into product. It will again fall down as a reactant. Only and only it will go into product when it reaches beyond this. When it reaches this much amount of energy, then and then only it will go into product. Okay. So activation energy is nothing but the minimum amount of energy. This is the minimum amount of energy that is required for your reactant to go into product. Minimum amount of energy required for your reactants to go into product. Is it clear now? Yeah. So there is certain energy barrier your reactant needs to cross in order to go to the product. Yes or no? Is it clear? Your energy does not get activated over here. Okay. So your reactants get activated. It got activated to such extent that it converts into product. Okay, and that peak energy, the peak energy, the complex that forms, we call it as activated complex. Then it goes to the product. So what happens? Reactant always in each and every reaction, reactant gains energy, activated complex, product. Reactant gains energy, activated complex, product. In each and every energy, each and every reaction. Is it clear, everyone? Now, yeah, come on, give me, all of you, give me yes. What sleepy are you? Come on, give me yes. Okay. So over here, write down this equation. Very, very, very important. Arrhenius gave us this equation. K is equal to A into E raised to minus EA by RT. Write down. A is nothing but Arrhenius factor. Yes, A is nothing but Arrhenius factor. EA is nothing but your activation energy. EA is nothing but activation energy in joule per mole. Yes. R is your gas constant. Yes. And T is nothing but temperature. Write it down, temperature. So he studied with respect to temperature. Arrhenius. Arrhenius studied with respect to temperature and gave us this equation. Now this A is called as Arrhenius factor or pre-exponential factor. Why pre-exponential? Because it is coming before the exponential E. That's why it is also called as pre-exponential. It is also called as Arrhenius, or it is also called as the frequency factor. Frequency factor because it depends on the collision of the gas molecules. How frequently the gas molecules are colliding. Okay. So write down this equation and done in the chat box, and please write down what is A, what is EA, what is R, what is T. Come on, write it down. Everyone, come on, write it down. Write it down, everyone, and done in the chat box. Write down what is A, what is EA, what is R, what is T. Done. Only 2 done. Come on, all of you. Done. Now look over here. This is called as Maxwell-Boltzmann distribution curve. But before that, look at this. Before that, look at this. Before that, look at this graph. Okay, look over here, everyone. Look at this graph. So over here, what we have done, we have taken the same equation. Look over here, everyone, on the screen, and please turn on your camera, everyone. Srishti, Darshan, Jyotsna, it's fine, Jyotsna, you are not well. Yazira, Vikram, come on, turn on your camera. Science fiction. Yes, exactly. Maxwell Boltzmann. See, in science fiction movie, if they do not understand anything, no, and if they want to give you something that is they cannot define, okay, they always give the name of quantum. Yeah, they always give the name of quantum energy, quantum mania, quantum realm. They they throw everything at quantum chemistry, quantum physics, quantum chemistry. Yeah. Okay, but over here, this is very understandable thing. Look over here, everyone. K is equal to A into E raised to minus EA by R. Yeah. So with respect to this, we have to convert this into graphical equation. That is Y is equal to mx plus C. So what I'll do, yes, I'll do it on another page. Yeah, better. You'll understand it better. Tell me honestly, from what you understand better, like if I use PPT or if I write it, what do you think? Yeah. Come on, give me a vote. PPT or writing, what do you think? What with what you understand better? Writing, mix of both. Writing. Okay, chalo. PPT with some writing. Okay. Should I take a vote? Chalo, I'll take a vote. We'll take a poll for that. Okay. PPT, writing, PPT, some writing, some writing, more PPT. And the vote. Let's see. Some writing more PPT. That means I should teach for more from PPT. Bapre. All of my students are confused. Oh my god. I'll share you the reason. Wrong option. You did not understand the answer 4 only. You saw the writing and you ticked it. Anyway, I understood. I'll keep the mix of both. Yeah, that is better. Yeah. I'll keep the mix of both. See, what I feel is solving numericals, solving derivations is a better way than teaching straight from the PPT where you have everything in front of you. Yeah. While writing, you guess a little bit, isn't it? While I write, okay, it is a psychological thing. You guess a little bit. Oh, this can happen, this can happen. Then I tell this, oh, this is happening. But if it is in the PPT in front of you, while deriving it, so it does not give a good thing. Chalo. Novice. Anyways, let us go ahead. So what did Arrhenius give us? K is equal to A into E raised to minus EA by RT. K is equal to A into E raised to minus EA by RT. Now to convert it into equation, what I have done, I have taken the log. So taking log on both the side, ln K is equal to ln A into ln E raised to minus EA. Oh, so sorry. A into E raised to minus EA by RT. Correct? So it is ln A into B. Log A into B, everyone. Log A into B. What is it? Log A into B. Log A into B. Parikshit, what type of symbol is this? Acha, ln. Okay. Log A into B, everyone. Write it down. Log A into B is nothing but log A plus log B. Correct? Log A plus log B. Correct, Parikshit. Correct, Harimahesh. Correct, Vishwanath. Jyotsna, it is not log A over B. Okay. Whenever it is multiplication, it is log A plus log B. Okay. Now look over here. So this what I'll write, ln K is equal to ln A plus ln E raised to minus EA by RT. Now which rule they are using? Ln A to the power B. So I'll write B ln A. So B log A. Correct? So ln K is equal to ln A minus EA by RT will come in front. So I'll write minus EA by RT ln E. ln E. Now just like why log 10 is 1, basically why log 10 is 1, everyone? Why the value of log 10 is 1? Because the base you take is 10. Okay, so that base get cancelled. Okay, that base get cancelled, so it is 1. Okay, similarly, if it is log E, ln means what? Yes, ln is nothing but natural log. That is, it is having the base E. Correct? So if I take this, it is 1. This is nothing but 1. Is it clear, everyone, what I have done? Yeah. So over here, ln K is equal to ln A minus EA by RT. So if I arrange this properly, look over here. ln K is equal to minus EA by RT plus ln A. Now come on, tell me, what is my y-axis? What is my y-axis, everyone? What is my y-axis? Come on, reply, everyone. What is my y-axis? Not the equation. What is the y-axis of this equation? Everyone, what is the y-axis of this equation? And what is the x-axis? That is more important. What is the x-axis? Yeah? What is the x-axis? Very good, Parikshit. What is the x-axis? Vishwanath, Hari Mahesh, Adil, Shrutika. What is the x-axis over here? Netra, Yazira. No, not complete EA by RT. Then what will be your slope, Vishwanath? It cannot be completely EA by RT. See, I'll write it like this. Look over here, everyone. I'll write this T separate. 1 over T. Okay, so this is Y, this is M, this is X, this is C. With the negative slope. Is it clear, everyone? So x-axis is 1 by T. Come on, write it down and done in the chat box. Come on. Go ahead, write it down. Write this down, come on. Write it down, everyone. Write this down and try to make graph on your own. First write it down. Those who have done writing, try to draw the graph on your own. Try to draw the graph on your own. I'll show you the graph, but first write it on your own. Come on. Write it on your own. Come on, write it down. Those who have written it down, tell me done. Come on. Come on, write this down. 1, 2, 3, 4. Come on, all of you. Done. Come on, all of you done? Okay. Shall we look at the graph now? Look at the graph. This is the graph. So this is the graph. Correct? No, not this. This is also the same graph, but this is the actual graph. This is the graph. Yeah. ln k is equal to minus Ea by RT. So slope is minus Ea by R. Yeah. Intercept, that is your C, is ln A. Y-axis is ln K. X-axis is 1 by T. X-axis is 1 by T. Come on, draw the graph. Is it clear, everyone? Is the graph clear? Chalo. Let us go ahead, everyone. Let us do this last one, then we'll jump to the questions. Let us do this last concept, then we'll jump to the question. You might have question on this concept also, so be ready. Look over here. So what if we consider for the two temperature? Okay, what if we consider for the two temperature? Okay, so I have taken the same equation, ln k is equal to minus Ea by R. Suppose I have T1 and T2. Suppose I have T1 and T2. So R T1, this K1. Okay. Similarly, I can write it for, and A is your Arrhenius factor. That will not change. That is constant. Okay. Similarly, I can write it for second temperature also. ln K2. Exactly same. Ea upon RT2 ln A. So if I subtract that, ln K2 minus ln K1, that is Jyotsna log A minus log B. That is Parikshit, Vishwanath, Srushti, Harimesh, log A minus log B. It is log A minus log B, log A over B. That's why it is K2 over K1 over here. K2 over K1. K2 over K1. Okay. If I subtract K2 minus K1, this gets cancelled. Yes, this gets cancelled. Minus EART2. What I am doing, everyone? This is second, this is first. I am doing 2 minus 1. Equation 2 minus equation 1. That's why I'll write over here EART2 from the equation 2 minus. Now minus will become plus. Plus EART1. EART1. Is it clear, everyone? Is it clear? Yes, is it clear? So if I rearrange it properly, everyone, if I rearrange it properly, EA R T1 minus EA R T2. Now I can take EA by R common. I can take EA by R common. So 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Over here also it should be ln. Over here also it should be ln. So finally, when I convert ln to log, yes, finally when I convert ln to log, what I'll do, I'll multiply this by 2.303. That I have written it in the denominator. So come on, write down this equation. Log K2 over K1 is equal to EA 2.303 R, EA 2.303 R, 2.303 R 1 over T1 minus 1 over T2. 1 over T1 minus 1 over T2. Come on, write it down. Is it clear, everyone? Come on, write it down. Okay. Write down this equation. You might have one question on this in the class assessment. Okay, write down the final equation. Log K2 over K1 EA over 2.303 R 1 over T1 minus T2. 1 over T1 minus T2. Done.